we have Rue Islam, who's going to talk about what's wrong with passkeys. Nice casual topic there.
Thanks, Tim. Morning, everyone. If you attended Tim and Matt's talk yesterday regarding, I think it was the myths around passkeys, you would have heard about some of the articles that were written over the last few years, criticizing passkeys, making hot takes about what's wrong with them. And reading all that got me thinking about, well, what do I think is wrong with passkeys? So this is what this talk is about. My name's Rue Islam. I work for a company called Dashlane, which is a password manager, and we've been a FIDO Alliance member for a few years, three or 4 years. I still consider myself a newbie in FIDO. Every time I come along to these events and join working group meetings, I'm learning a lot from folks like Matt and Tim and others. So I encourage everyone to kind of lean into the FIDO Alliance. It's a great place to learn from the experts. So we're here because of this thing, the password. And password managers have been trying to fix the problems that are associated with passwords, and FIDO Alliance is really trying to solve them for good. However, I think this is the first problem, which is the vast majority of users are still using passwords, and a lot of them, well, I would say some of them are relying on their heads to store the password. Some of them are hitting forgot my password link. Some of them are maybe using an Excel file to store their passwords, but they're not using a password manager. Our friends at Bitwarden did a study back in 2022. They commissioned a study where they found that only 30% of internet users are using a password manager. And if you look into this study, you'll notice that this number is a bit inflated because the participants of this study were from developed nations, like 6 of the biggest developed nations, so US, UK, Germany, France, Australia, and Japan. So if you look at the global internet user base, that number's going to be much smaller. So why is this a problem? Because if we want people to start using passkeys, we need them to stop doing that thing and start relying on a piece of software or a piece of technology, which is something we're calling a credential manager, sometimes a password manager, sometimes a passkey provider. And there's a good reason why we need them to stop using their heads and move over to technology. It's because it's the technology that does what they cannot do themselves. Creating strong and unique credentials is not really possible in our heads. The technology that applies that non-phishability, the origin binding, we're not very good at that. We get tricked by websites that look like the original website. And we definitely can't do asymmetric cryptography, which is necessary in order to protect the private key locally and yet distribute the public key to the relying party. So to get all of these users that are currently relying on passwords to start using passkeys, they need to make a big shift, and they need to start using a password manager, maybe the default credential manager, that comes with their system, maybe one that they'll pick themselves. But that's going to require a behavior change, and I think as an industry, that's a problem we need to tackle. So I would say that's something that's wrong that needs to be solved. The question here is, once we've got them to start using a passkey provider, what is it that protects that passkey provider? And almost all passkey providers, credential managers, are protecting the software with something memorized. So the thing that we tried to get rid of is kind of still there. Now it's simplified to potentially one credential that the user has to remember. And the reason why they need that sort of thing in their head is because these passkeys are being synced across different devices. And in order for those credentials to be synced, they need to be encrypted, pushed up to the cloud, brought down to another device. And And that memorized secret is helping in that process, which we'll look at in a minute. So what's the problem here? The problem here is when you are registering a new device, let's say you run over your phone because you can't drop it in the toilet anymore because it's waterproof, or buy a new laptop, you need to now bootstrap that device for your credential manager. And you need to kind of use your knowledge factor at this point. And obviously, most credential managers don't let you just directly use your master password or the password to directly log into a new device. They'll add some form of 2FA. And a lot of these factors are phishable factors. So the password itself is phishable because it's a password. Some providers, like our friends at 1Password, will augment that memorized password with another factor, which is like a secret key, but it's something that you can type, so it's phishable. A lot of the OTPs, as I mentioned, are going to be things like email OTP, typically SMS OTP, code from an existing device. You know, if you've already got a provisioned device, you display a code, you type that into the device you're provisioning. Again, you're typing something into somewhere that's phishable. And now, tried and trusted TOTP 2FA is absolutely phishable. There is another way to kind of protect passkey providers, which is, I'm just going to call it risk engine, because I don't actually know what goes into these things, because they're typically used by more sophisticated providers, typically like the system providers. And that's essentially judging, is this new device provisioning something that I want to allow, given the signals that I get from the user? Maybe it's an IP address coming from a region that the user doesn't typically visit, or the login's happening at a time of the day that the user's not typically active. So those signals go into that risk engine. But I would say that all of these methods are phishable, so it doesn't really matter which one you're using. You're just raising the bar or lowering the bar a little bit. Ultimately, they're not FIDO-based, so they're phishable in my opinion. While I was putting together this talk, the committee that goes through the talk was asking, well, you've not talked about biometrics, and it's true, I didn't really think about biometrics, but it does have a role to play here. I think biometrics shine when you're unlocking your existing device. So if you've got your password manager set up on your phone, you can set up biometrics, and it works great. And the reason it works great is because it's a local factor, right? The biometrics, the templates stay on that device. The hardware developers have built great technology to make sure that that's the information around your fingerprints or your face is not leaving that device at all. And the way I look at biometrics is it's a convenience factor to a local device secret. So biometrics fail. Like if you've washed your hands too much, or your appearance is different, it's going to fail. And what do you do when it fails? Well, you fall back to some sort of low entropy secret that you either tap into your phone or swipe around on your screen to access the device. So a local device knowledge factor is actually a great authentication method for a local device. So where these things fall short is when you're bootstrapping your new device, you can't use any of that, because the great thing about biometrics is it's tied to a single device, so you can't now project that onto your new device. So biometrics don't really help here. They don't help for new device provisioning, recovery flows, which is another way of doing a new device provisioning. So the phishability of the passkey providers that use biometrics doesn't really change because you're using biometrics. So 2FA, I don't think cuts it. Even though a lot of the providers use 2FA today, I think it's not gonna be something that's acceptable as time goes on. So we know that passwords can be kind of replaced by passkeys. So why don't we just augment that weakness of that knowledge factor with just another passkey? Well, I think this is problematic because typically when the way the ecosystem is set up, you need to decide what passkey provider you want to use. It might be the system one, it might be a third-party one. But if you then need the ability to protect that passkey provider with another passkey provider, you need to also switch that passkey provider on. And now you've got two passkey providers and I don't know what's protecting the second passkey provider, so that's not a really workable solution in my opinion. So yes, you do add phishing resistance if you add a syncable passkey to protect your passkey provider, but it's not a usable solution in my opinion. Third option, I think, is to use a security key, which is something a lot of passkey providers provide. So you can go into, if you were willing, you can go into the settings, find the high security options, and if you have a security key, you can set that up. I think we can do better, and I'll explain why. But that option works. So just to recap, regular access relies on an existing provisioned device. Typically, the knowledge factor is used to unlock that device or unlock the application to access your passkey provider. Biometrics work great. In my opinion, there's no phishing risk inherent in accessing your regular device. The risk is on when you're either provisioning a new device or recovering your passkey provider, because the trust is missing on that new device, and all this 2FA sort of dance that you're doing is just to raise that trust level. The common thing amongst these two sort of flows is the fact that, as I said, security keys are a valid option, but I think we can do better. And the reason I think security keys aren't foolproof is it's still a 2FA factor that you're having to switch on. And with enough social engineering, you can be convinced to switch it off. So it's good, but I think it's not foolproof. But common amongst these two flows is this knowledge factor. What is this knowledge factor? What does it do? So typically, a credential provider, passkey provider, that knowledge factor, which is typically called a master password, will be converted into some sort of symmetric key ready to encrypt and decrypt data. And there's algorithms such as PBKDF2 or Argon2 that are computationally expensive in order to generate some sort of symmetric key. And the reason why they're computationally expensive is because if an attacker were to get hold of your vault and they had a big dictionary of passwords to test, it's difficult for them to test them all because it just slows them down. But if they know your master password, it doesn't matter what algorithm you're slowing down that key derivation, they're going to have access to your vault. So what if we were to try and replace the master password with a passkey? Well, this doesn't really work because passkeys are designed for authentication. The cryptography involved isn't the right flavor of cryptography that we need. But there is an extension in the level 3 WebAuthn spec, which is called WebAuthn-PRF, which does give the ability to the passkey to do symmetric encryption. So what is WebAuthn-PRF? So WebAuthn-PRF, it's still a passkey. We're not talking about something else. You're still getting all the benefits of a regular passkey. It's designed for authentication. It involves asymmetric keys, like we've seen, used to sign and verify. On top of all that, you get some extra thing. And that extra thing is symmetric keys, or something to encrypt and decrypt data with. And PRF function means pseudo-random function, for those that are curious. I just want to emphasize that RPs don't really need to worry or need to go and look up what WebAuthn-PRF does, because 99% of RPs are never going to need to implement PRF in their service. The regular passkey works for you. That's what you're replacing the password with. If you are already encrypting data from your password entry, maybe that's interesting, but regular RPs, on the whole, won't need to worry about what this WebAuthn-PRF is. So I'll quickly explain where this WebAuthn-PRF fits in, but I'll start with an explanation of where the credential manager sits in this picture, and hopefully you're familiar with now this authenticator side and the RP side. So the RP sends over a challenge once a passkey is already set up. It gets signed by the authenticator using the private key, so the credential manager, whether it's Apple Passwords, Google Password Manager, or a third-party provider. And then it's returned back to the RP to be verified with the public key. So that's how a regular passkey flow works. Now, where this is useful for a credential manager with PRF, now, actually, the credential manager is the RP. And what that means is the credential manager is relying on an authenticator to sign in. And the credential manager is now sending over the challenge, but includes a salt value. So this is part of the WebAuthn PRF extension. And the authenticator is doing something extra. And the extra thing that it is doing is generating this PRF secret, which the credential manager can use for encryption and decryption purposes. The question is, if the credential manager is the RP, what is the authenticator? And we saw before, we can't have another synced provider. Well, we can, but it's not ideal in my opinion. It's not really great UX, considering you have to enable multiple passkey providers. So what fits well here, in my opinion, is security keys. The reason is security keys, unlike synced passkey providers, you don't need to switch anything on the system. Like for the last few years, the FIDO 1, as it were, the first version of FIDO was to make sure all our operating systems and browsers have the necessary software to just make these things work. And that's great because you can just use it out of the box, as it were. So just to recap, who's the authenticator here? Because this is starting to get a bit confusing. So we have a passkey that is stored on a security key, protecting the passkey provider, which is then protecting synced passkeys that are being used for your regular RPs. So there's this sort of passkeys all the way through, and the trust is on accessing the passkey provider. And just to kind of be clear, currently there's no way that a signal could be given to the RPs that this is happening. There probably will be work going on in the future that could divulge to RPs the kind of passkey provider that's being used or the situation the passkey provider is in. But for now, it's more the case that the user's interested in protecting the passkey provider. The RP won't really learn about that much. Well, what's wrong with this? What's wrong with PRF and security keys? Well, first thing is that passkey support is great. WebAuthn PRF the support's not quite there yet. It's a bit patchy in places. There's some cases where it works great, other cases where it just doesn't work because the necessary plumbing, the CTAP spec plugged into the operating systems isn't there yet. And hopefully it will be there. User experience-wise, well, since 2022, and for good reasons, we've seen, let's say, a prioritization of synced passkeys and kind of like a demotion, I'd say, of device-bound security key experience, meaning most users are going to want the synced passkey experience. Not everyone is going to want a security key experience. So it makes sense the UX is deprioritizing it in favor of synced passkeys. Well, in this case, when you really do want to use a device-bound passkey or a passkey on a security key, the UX as it stands doesn't really help your user. Now, in the level 3 spec of WebAuthn, there is something coming along called WebAuthn Client Hints. Currently, this has inconsistent support, and if that were to have better support, then at least the RP, like the credential manager being the RP, has the opportunity to provide a better experience. And lastly, adoption. Well, security key adoption is, in my opinion, still low, and that's the reason why we have synced passkeys, because it's just an easier to adopt authentication method. But I also think security key adoption is low because it's a 2FA mechanism where if the mental model was something else, it could have a better adoption. The other issue is if you're going to protect a passkey provider with a security key, you can't then add phishable recovery methods. And right now, the best recovery method is to have another security key set up and then throw that in a cupboard or in a safe somewhere in order to recover if you were to lose your key. And just to be clear, it's not just losing the key. It could be resetting the key. It can be accidentally deleting the credential on the key. There are, as has been mentioned in previous talks, like foot guns that can cause you to lose your ability to generate that symmetric key. So recovery is important. So in general, I think, as a community, as platforms, as browsers, we could do more to raise the support level of security keys, particularly around PRF. And that doesn't necessarily mean we dilute the experience of synced passkeys, because those RPs are going to give signals saying that they really want a particular experience. So just to recap the situation from my point of view regarding passkey providers, currently, password and OTP is not phishing resistant. It's, in my opinion, not super easy to use because the OTP might be phishing in a particular email account. It might be an SMS. Risk Engine is like the platform providers, that what they do, it's better, but I don't think it's totally phishing resistant. I would argue it is kind of easy to use because currently we have either one provider or another, Google or Apple, and you kind of get used to setting up new devices. So they can invest a lot of effort into bootstrapping their new devices and their new accounts. As we saw, using a synced passkey as a sort of 2FA mechanism is phishing resistant, but it's a nightmare to use, so it's not really easy to use. Device-bound passkey with PRF is absolutely phishing resistant, just as phishing resistant as passkeys, or device-bound passkeys, but it's not easy to use because of all the issues I raised in the previous slide. So my call to action from this talk is really for passkey providers to just raise their game. A lot of these passkey providers were password managers previously, and when you're protecting phishable credentials, protecting yourself with a phishable credential is probably not an issue. When you're protecting non-phishable credentials, but protecting yourself with a phishable credential, I think that starts to be an issue. And you can add non-phishable authentication options for your users, even as 2FA, that's okay. The key thing here is to make the security easier to use. Platforms and browsers, as I've been kind of repeating here, we need better support for WebAuthn and PRF. It is still an editor draft spec, but as soon as we can get better support there, especially as well as with the WebAuthn client hints, we can start seeing these experiences come to a lot of products, not only passkey providers. There'll be other types of products that would want to do the same type of thing and add a layer of phishing resistance. So what's wrong with passkeys? Actually, passkeys are great. They're phishing resistant, they're faster and more reliable. Passkeys are simply a better replacement for passwords. However, passkey providers currently mostly rely on phishable credentials. Non-phishable authentication is possible, but we need that platform support. I'm really repeating this because it's important. Just the last point here, just because your passkey provider is not phishable, we still have the opportunity to export the credentials. So again, the signal to the RP is not going to be very helpful in this situation. The passkey can be shared, and the recipient of the shared credential may not have set up their passkey provider, even if it's the same passkey provider, at the same level of protection as the individual who's shared them the credentials. So there is a lot of complexity in terms of how we represent the level of protection the passkey provider has. I'm sure this will be a big, long discussion within FIDO for quite some time, and eventually we'll get there, but for now, there are no signals that can convey this, especially as these AO GUIDs are not attested. So passkey providers are being the focus of attacks, and I think in the next few years we need to really change that if we want passkeys to be successful. Thank you so much for listening.
All right, thank you, Rue. We have about 5 minutes for questions. I don't see any in the app, so we'll take some in the room. Yep.
Thanks. You mentioned biometrics is not a great way to recover or set up a new device because of the boundness to the previous device. What about cloud-based biometrics, where maybe there's a reference image in the cloud that can be trusted, has a different trust model associated with it, and you do a bit like an IDV process, but referencing back to that trusted image?
I specifically wanted to talk about what the types of biometrics are commonly available to consumers. But absolutely, if there are like proprietary or non-platform biometric types that are more cloud-bound and can be conveyed onto multiple devices, yeah, absolutely, that's helpful. But I think that comes with other problems, which is those templates being somewhere.
Any other questions in the room? Yes.
When you're talking about using a security key to protect your credential manager, what are the sort of implications of the fact that everybody who's ever had a security key permanently in their laptop and bought the really tiny ones where you never remove it and then they walk away from their laptop and forget that it's actually also the path into their credential manager, and now you've removed every security factor except for physical presence?
Yeah, I didn't quite mention it. That's a great question. I didn't quite mention it in this talk, but it's not just a possession factor. There is a knowledge factor. Whenever you generate a resident key on a security key, you're prompted by the system, thanks to standards, to set up a low entropy knowledge factor for that specific key. So yes, if someone picks up my YubiKey or OneSpan key or any other standards-based key, they can try to use it. They're going to be confronted with a low entropy secret, and if my low entropy secret is very easy to guess, then they're in. If they try too many times, it will be locked out. So there is a protection there.
Probably do 2 more.
Sorry, David.
Thanks for the talk, Ru. So typically, right now, I have to steal your security key and steal your 4-digit PIN, and then I am in. So usually the question is, again, now we are back to something that looks like password and is a password. We are calling it PIN. What is the threat modeling around it? Why is it better than passwords?
It's a great question. I think especially when you're developing this stuff, you get kind of caught up in all these elaborate scenarios. But the biggest threat today is remote attacks, remote phishing attacks where no one's coming to your house to pick up your key. Yes, those attacks exist and those threats are real, but it's remote attacks that we're focusing on, so I think it's okay. David has a question here. Sorry, if that answered your question. Just want to get David in before we run out of time.
I don't think you should use the mic because you're in front of the
Oh, sorry.
Do you want to
Just want to repeat it, yeah.
Just don't be in front of the speaker.
So for the passkeys, you talked a lot about third-party passkey providers and kind of the turtles all the way down. Have you thought about first-party? So basically using hybrid on the new device to do PRF from the old device?
Yeah, actually, when I showed the image of selecting multiple providers, that wasn't third-party providers only. One of those providers could be first-party, but I think the problems still stand. Whenever you generate a new credential, you're going to be confronted with 2 options, like which provider do you save your credential in? And I think we've already heard people who forget which provider they've saved their credential in. So I think it's okay, it's great that we're able to have multiple providers enabled at the same time, but I think it comes with some other problems. And if we want people to have easy-to-use security, then I think that's going to be problematic.
All right, we can do one more quick one. All right. Well, thank you, Ru.
Thank you all.